Welcome to AI University, the hub of intelligent conversations and learning. Today, we embark on a fascinating journey, building a neural network from scratch. It's an exciting adventure through the realms of Python, TensorFlow, and PyTorch. Dive right into the first step, installing the necessary Python libraries. These include NumPy for numerical computations, Matplotlib for visualizations, and of course TensorFlow or PyTorch, the heart of our neural network. Once installation's complete, initiate the coding phase by importing these libraries into the Python environment. This action equips the toolbox with everything required to build the neural network. Following this, it's time to create a dataset. A neural network needs data to learn, similar to how humans need experiences to gain wisdom. Use the NumPy library to generate a dataset. Keep in mind, the quality and diversity of the data significantly influence the neural network's performance. With a dataset ready, the next step is to design the neural network's architecture. This step involves defining the number of input, hidden, and output layers, along with the number of neurons in each layer. Remember, the input layer size corresponds to the number of features in the dataset. The output layer size relates to the number of predictions to make. The hidden layer, the neural network's powerhouse, is where the magic happens. It's where the network learns and makes connections. Now, initialize the weights and biases for each layer. These are the parameters that the neural network will adjust during the learning process. Start with random values, and as the network learns, it adjusts these values to reduce the error in its predictions. Scene script. Proceed to define the activation function. This function decides whether a neuron should be activated or not based on the weighted sum of its inputs. A popular choice is the ReLU or rectified linear unit function for hidden layers and the softmax function for the output layer. The next big step is to define the loss function, also known as the cost function. This function measures how far off the network's predictions are from the actual values. The objective of the neural network is to minimize this loss. With the architecture set and the functions defined, it's time to train the neural network. This process involves feeding the network the dataset, allowing it to make predictions, and then adjusting the weights and biases based on the error calculated by the loss function. This cycle repeats for a set number of iterations or until the network achieves an acceptable level of accuracy. Finally, evaluate the neural network's performance using a test dataset. This dataset should be different from the one used for training to ensure the network can generalize its learning to unseen data. To recap, building a neural network involves installing and importing the necessary Python libraries, creating a dataset, defining the network's architecture, initializing weights and biases, defining the activation and loss functions, training the network, and evaluating its performance. Hopefully, this journey through the labyrinth of neural networks has been enlightening. Remember, practice is key when building neural networks. So don't hesitate to experiment with different datasets, architectures, and functions. Thank you for visiting AI University. Please remember to like, share, and subscribe. Don't forget to turn on notifications to stay updated on future lessons in the world of artificial intelligence.